Hello guys, welcome to Relax School. My name is Jyoti and I'm a CMA finalist. In this video, we are going to talk about transportation. This is our first video on transportation and we are going to cover basic concepts, procedure, what is a balanced and unbalanced problem. For this purpose, I am using CMA Final Paper 16 Strategic Cost Management Study Material. For the sake of self-study students out there, I will say this module 7 has 42 pages with 8 illustrations. Now let's start with our first concept, which is transportation. Transportation is a special kind of linear programming problem. If you have no idea about what a linear programming problem is, I have made a playlist on that. I will put it in the description. If you are curious, you can go and watch it. Now, in a linear programming, we have objective function and subjective constraints. So the objective function in the case of transportation is minimum transportation cost. When it comes to constraints, we have constraints on supply and demand. Now let's see, we can also solve a transportation problem using linear programming. However, it is such a hassle, forming the equations, taking it to simplex method and solving it from iteration to iteration. It takes a long time. So there is much easier method which we are going to learn now. But first, what exactly happens in transportation? See, in transportation we have sources and we have destinations. See, sources can be plants or manufacturing units where there is supply of goods. Imagine if I am a company, I have different plants, different manufacturing units, different places where there is supply of goods available to the people or customers who want those goods. So simply, sources are these places where there is supply for goods. In the same way, we have destinations. They can be retail shops, warehouses, or whomsoever you can call it, where there is demand for these goods. So basically, there are some sources where there is supply of goods. There are some destinations, call it customers, they have demand for these goods. In a typical transportation problem, the transportation cost between sources and destinations are known. So our job is to transport these goods from different sources to different destinations. Now, if you look at objective, our objective is to minimize the transportation cost while satisfying the supply and demand. Okay, how do we do that? For this, we need to allocate number of units that should be transported from sources to destinations. What was this supposed to mean? Let's understand it with an example. Now, if you look at this example, it has two sources S1 and S2. And it has two destinations D1 and D2. As I said, we know the costs between different sources to destinations. So here from S1 to D1, the transportation cost is 5 rupees, and from S1 to D2, the transportation cost is 7 rupees. From S2 to D1, the transportation cost is 6 rupees, and from S2 to D2, the transportation cost is 9 rupees. Sources are the places where they have supply of goods. In this case, if you can see, S1 could supply 50 units, S2 can supply 20 units. In the same way, we have demand when it comes to destinations. These people want the goods, right? So D1 needs 20 units and D2 needs 50 units. So now if you look at the total demand and total supply, the total supply is 50 plus 20, 70 units. And the total demand is 20 plus 50, which is also 70 units. Now this is what a transportation problem would look like. And our job is to allocate the number of units that should be transported from sources to destinations. So let's say if I allocated 50 units here, this basically means I'm willing to transport from S1 to D2 50 units. Because of this allocation, what happened? The corresponding supply of this 50 units is satisfied, and the corresponding this demand of D2 is also satisfied. In the same way, if I allocated 20 units here, This basically means I'm willing to send from S2 to D1 20 units. So because of this allocation, the demand for D1 is satisfied and the corresponding supply of S2 is also satisfied. This is basically what allocation means. Even though I satisfied all the supply and demand constraints, our job is not to just satisfy the supply and demand. This is a feasible solution. This basically means I am satisfying the constraints. However, I cannot call it a final solution. Why? Because my job is not just to satisfy the supply and demand, but my job is to minimize the transportation cost. For this, we need to follow a proper procedure. But before that, there is something which is very important, which brings us to concept number 2, which is balanced and unbalanced transportation problem. See, every time we solve a transportation problem, the first thing that we need to do is we need to check if the total demand is equal to total supply or not. If the answer is yes, it is a balanced problem. Then we can proceed to solve the problem using any of the methods. However, let's say the total demand is not equal to total supply. We will call it an unbalanced problem. Then we need to convert this unbalanced problem into a balanced one, which basically means the total demand should be equal to total supply. For this, there are some simple steps. So we need to add dummy sources if demand is more, or we need to add dummy destinations if supply is more. To understand this, let's take an example. Let's say there are two sources S1 and S2, and there are two destinations D1 and D2. Let me take the corresponding costs for, let's just say 3, 5, 4, 2. Let me write the supply also. See, from S1, there is a supply of 30 units. From S2, there is also a supply of 30 units. Alright, now let me write the demand. So D1 wants 30 units and D2 wants 20 units. Now look at the sum of supply and demand. See, the supply is 30 plus 30, 60. The demand is 30 plus 20, 50. You can clearly see this is an unbalanced problem. The total supply is not equal to total demand. Here the supply is more than the demand. If the supply is more, we need to add dummy destinations. Let's take a dummy destination D3 to balance the problem. So the costs for D3 are 0 and 0. So this basically means from S1 to D3 the cost is 0, and from S2 to D3 transportation cost is 0. Why? D3 is a dummy. See, D3 doesn't really exist. It is for convenience to solve the transportation problem. So the costs were not real. Okay, so we are taking it as 0. Now here we have to write the difference of total supply and demand so that we can balance the problem. Let's see, the total supply is 60 and the total demand is 50. So if we add these 10 units here, so now the total demand has become 30 plus 20 plus 10, which means the total demand here now is also 60. Now because the total demand is equal to total supply, this is a balanced problem and we can use the methods to solve the transportation problem. In the same way, let's also see the case where the demand is more. Now I will just write now let's take the demand as 30 and 30. From D1 they need 30 units, D2 also needs 30 units. Let's say the supply as 30 and 20. So this basically means S1 is capable of supplying 30 units and S2 is capable of supplying 20 units. Now let's add the total supply and total demand. The total supply is 30 plus 20, 50. The total demand is 30 plus 30, 60. Now because the demand is more, we need to add dummy sources. We will do that. We will add a dummy source S3 And we will write the costs as 0 and 0 because S3 is not real, it's a dummy. And we will write here the difference between the total supply and demand. So 60 minus 50 again, which is 10. So if I write 10 units here, am I balancing the equation? Yes, 30 plus 20 plus 10 is 60 units. So the total supply is equal to total demand now. It has become balanced. Now I can use any of the methods to actually solve the transportation problem. Now we have understood how to approach a transportation problem. What is the approach? We need to always see if the transportation is balanced or not. Right. Now we can understand the procedure. Which brings us to our third concept, procedure to solve the transportation problem. The first step in this is to find a basic feasible solution. What is a basic feasible solution? A basic feasible solution should have m plus n minus 1 number of allocations. See here, m is number of rows and n is number of columns. If you remember our example that we talked about before, this was the example. And if you see here, we have 2 rows and 2 columns. As I said, a basic feasible solution should have m plus n minus 1 number of allocations. That basically means I have 2 rows plus 2 columns minus 1. That means I need to have 3 allocations to call it a basic feasible solution. Right. However, how many allocations did I make? I made only 2 allocations here. This is the reason why I said this is a feasible solution satisfying the constraints. Satisfying the constraints is not enough. We have to have m plus n minus 1 number of allocations. So, how do we find this basic feasible solution? For this, we have 3 methods. The first one is northwest corner method. The second one is least cost method. And the third one is Vogel's approximation method. We will understand all these 3 methods in next video. For now, let's understand the procedure. We have completed the first step, finding the basic feasible solution. We understood it in simple terms. What was that supposed to mean? Our second step is to test this basic feasible solution for optimality. Right, if this basic feasible solution is fetching me the minimum transportation cost or not. Is it optimal or not? We need to test it. For this, we have modified distribution method, which is MODI method. Now, while finding the basic feasible solution, we made some allocations, right? For those allocated cells, we need to use this formula. This is our first step. So the formula is Cij is equal to Ui plus Vj. What is Cij? Cij is nothing but the cost. And I and j are positions. I is the position of row and j is the position of column. Let's understand it with an example, right? If this is S1 and S2 sources, D1 and D2 destinations, this is C11, this is C12, this is C21 and this is C22. So first row, first column, first row, second column, second row, first column, second row, second column. And these are nothing but the costs. Let's say S1, S2, D1, D2, 3, 5, 4, 2. This basically is the cost for C11. This basically is the cost for C12. You're getting my point, right? The costs were already known to us. I and J are nothing but the positions. And using this formula, we are going to find the values of U's and V's. U is nothing but a row value and V is nothing but column value. It is okay if you find it confusing or anything. You just understand the basic point, right? For allocated cells, we are using this formula and finding the values of u and v. This is our first step. Our second step is, for unallocated cells, we are going to find the opportunity cost. How do we find it? We have a formula, delta ij is equal to Cij minus ui minus vj. Cost values are known to us. Using this formula, we have found the values of u and v. So using this whole formula, we are going to find the opportunity cost. What is an opportunity cost? See, this basically means we are trying to understand, is there anywhere we can reduce the transportation cost? Is there any opportunity for us? Can we look for the costs and feel like, oh, here if I allocate more, my transportation cost is being reduced. Right, this is what you are trying to understand. For all the unallocated cells, you are trying to understand if there is an opportunity to reduce these transportation costs. Now, if the opportunity cost values are non-negative, then the solution is optimal. Non-negative means it has to be either 0 or positive. If all the opportunity cost values for the unallocated cells are non-negative, then the solution is optimal. This basically means the allocation that you made in the basic feasible solution, these are going to give us the minimum transportation cost. If the opportunity cost values, however, if they are negative, then you are going to draw a loop and you are going to reallocate. After reallocation, you are going to follow all the steps again, which basically means that for the reallocated cells, you are going to use this formula and you are going to use this formula and you are going to check if there are any non-negative values again. Right, if they are going to give us non-negative, solution is optimal. However, if it is not, then you are going to continue following all these steps until optimal solution is reached. This basically means after drawing the loop and reallocation, you are going to follow all these steps over and over again until you are reaching the optimal solution. You are trying to improvise the solution and reach to a point of minimum transportation cost, and you are going to call it a optimal solution. This is simply the procedure. And when you are drawing a loop, there are some things that you need to understand, which we will completely get, by the way, when we are trying to solve the problem. This is it for this video, guys. In the next video, we are going to discuss about northwest corner method, least cost method, and Vogel's approximation method. When you are comfortable with finding the basic feasible solution, we will move forward and talk about modified distribution method. I assure you we are going to cover all these steps, and it is not as complicated as it seems. For more such content, like, share and subscribe, and don't forget to comment your thoughts below.